In this video I'm going to look at some of the display options that allow the display of data using a set of points rather than a set of lines connecting points. Data are plotted in the active tile using the set of parameters that are available for changing on the tile display parameters dialog window. The fact that we have points drawn here is because of the arrangement of these three options here: draw lines, draw points, fill below. These three tick boxes alter what you see drawn in the active tile. So for example, if I tick draw lines and untick the draw points, then you see a set of curves where the curves are joined together by lines and they're coloured according to a set of colours that are defined for spectra when overlaid in the active tile. If rather than using draw lines I draw points and press apply, you can see that the colours that we use to draw the lines are now drawn as the colour on the outside of each one of these shapes. So the first one drawn in this list is a Parson G5 spectrum, and it has a yellow interior with a red exterior. So this curve here represents the Parson G5 spectrum, and the colour that we see drawn within the shapes are determined by a colour palette that is the synthetic envelope palette. So the spectrum palette defines the colours that would use to display these data. So we've got red here corresponding to Parson G5 spectrum, and when I look at the synthetic envelope palette, the custom colours here show the first one is yellow, and that's the interior colour of this first point. Therefore the first spectrum in the list when displayed in the active tile will have shapes that are red around the outside and yellow as the interior, and each different spectrum has a different combination of a colour taken from the spectrum and a colour taken from the envelope. Now perhaps I should say what the envelope means. The synthetic envelope, this is a curve that is plotted whenever we have a synthetic model. So we've got components and a background, and when we sum the background and all the components, we end up with a curve that approximates the spectrum, and the colour of that curve will be the colour that is defined by this custom palette here. And when data are overlaid, just as the spectrum colour changes, the synthetic envelope colour changes too. So when we have points, we will see the exterior with the spectrum colour and the interior with the synthetic component colour. The colour dialog window allows the adjustment of colours using this custom colour palette we see here. If we say define colours, then it's possible to select a colour and modify the colour by making some kind of selection, either using adjustment here or maybe selecting one of these colours here. But nevertheless, once we've chosen a colour, we can update the palette with that colour, and then it will change the colour within of the spectrum, or in this case of the synthetic envelope. Now, I'm not going to do this in this instance. The reason I was explaining that is because the same idea applies to these shapes that are used to draw the points within a spectrum, and this option here, shape option list, provides a means of editing the shapes we see used to display spectra. The shapes that are actually displayed are the custom shape order, and these are all the same shape. Hence we see all the same shape as we display these data overlaid. However, this does not have to be the case. We could select a different shape. So for example, I'm going to select this circular shape with a green interior. Now the green interior has a meaning. So if I update the entry, you can see how the green interior circle is now the first one in the entry, and the selection has moved to the next diamond. So if I wanted to make this a star, I could, and so it's updated with a star, or I could use a square, and so I could go through and choose a set of shapes that would be appropriate for the data I want to display. Now in this case, what I'm going to do is I'm going to select all circles, so we can see what happens if I just go through and I change each entry in this list so that the entire list becomes circles, and the display of the data is based on this custom shape order. And when I say OK and then press apply, we can see that the data are now displayed using circles that consist of an exterior color from the spectrum and an interior color from the synthetic envelope. And the reason that we see two colors is because I selected a shape that had this green color on the inside with a boundary color of black. So if I choose a different shape, for example the circular shape without the green color, and I go through and update the entire list, press OK, press apply, we now have circles that are just the exterior color that comes from the spectra. If I choose a square, for example, they don't all have to be the same either, so I could choose a square for the first two, and then a diamond for the next two, and then a circle for the next two. And when I press OK and apply, I then have two squares, two diamonds, two circles, and these are now indicating the different sources for these data points that are plotted in this display tile.